Assalamualaikum and good morning. Okay, welcome back to our session. So today we are going to discuss tutorial 7 question number 4. I will show you how to solve this problem, but I find the solution is a little bit different from this. We're supposed to find, after we uh, develop the coordinate equation, so we have to come up with the final solution with this ODE. Okay, but I have hard time to find it, so I need to discuss with the electronics college regarding this. However, the way we solve this problem will be shown today, but the solution will be different. So I tried to explain. I may find the solution next time. Okay, next session. Okay, so in order to solve this problem, you can see here. Okay, first of all, when we study in our book, our lecture, so the OLC circuit, it's in series form. Okay, in the series circuit. So, but now it's in parallel circuit. So, what should we do? So you can see here we have two. You can say mesh or loop. Okay, so this is one loop. Okay, this is one loop, which, okay, one system, but it's connected by this component. So usually this one is we call it branch. Okay, so this is the branch. So this is also the branch. So in the parallel system. So this is the branch. So this is the branch. Okay, and then this is we call it node. Okay, so this is the node. Okay, so this is the node. This is also node. Okay, okay. So in based on the uh, Kirchhoff's law, Kirchhoff the law. Based on the Kirchhoff law, he said the first law. He said that okay, so they have uh, he said that okay, the in the knot, okay, in the knot. So this is knot, at the knot, okay, at the knot. So the current, okay, the current, the intercurrent. Okay, so this is intercurrent equal to the exit current. Okay, so intercurrent equal to the exit current. Okay, so it's equal to, and then another uh, another uh, theory, meaning the Kirchhoff law again, Kirchhoff voltage law. Okay, this is called Kirchhoff law, the first law, and then another one is Kirchhoff voltage law. Okay, he said that in the system like this, so uh, the voltage, okay, so sigma of the voltage loss equal to 0. Okay, so this is the what he said with the experiment. So in our case, okay, let us start with the current. Okay, so let us say the current is flowing from here. Okay, so this is EY, E1, I1. Okay, and after that this is I2. Let's say this is I2, and we have another one which is this is I3. Sorry, this is I3. Okay, this is I3. So I1, I2, and I3. And then we have, for Kirchhoff voltage law, we have, this is loop 1. Okay, so this is loop 1, and this is loop 2. Okay, so this is loop 1, this is loop 2. Sometimes they call it mesh. Okay, no problem. We have loop 1 and loop 2. Okay, so loop 1 it consists of this component, loop 2 will consist of this component. Okay, so based on this law, we can see that based on this law, so we have at this knot. Okay, let's say this is A knot and this is B knot. Okay, so at A knot, at A knot, okay, the current will be equal to I1 is equal to, based on this one, this direction up to you. Okay, you can set any direction, but it's better to follow. I mean, we have pre-justification based on the current circulation like this. Okay, like plus, it go like this, and so on. But if you cannot define, no problem, just define any direction you like, because later you have minus, I mean this is again what you assume. Okay, okay, I1 is equal to I2 plus I3. Okay, something like this. So I1 is equal to I2 plus I3. Okay, and then we have at loop 1, okay, at loop 1, so based on the Kirchhoff law, we have, this is the voltage, so we got 20 volt. Okay, 20 volt plus, I'm not sure, 20 volt, let's see, this is voltage. So loop is like this. So when the loop is uh, go follow the, I mean go the same direction of the current, so it will be minus. Okay, the voltage will be minus. So that's why here you can see I is this direction, so we got this is the resistance, and then this is the uh, inductor. Okay, so this is inductor. So for the resistance, as you know, resistance, the voltage is equal to R1 multiplied with I1. Okay, voltage, and then after that the current will pass through inductor, so the inductor will be minus again because the same direction of I. So it will be equal to, inductor is equal to, what is the voltage of inductor? We already studied. So equal to L1 d I1 divided by dt. Okay, please open the tutorial. Okay, we did uh, elaborate this explanation, meaning that if a resistor, so what is the voltage? If inductor, what is the voltage? And then if this is capacitor, what is the voltage? Okay, so now this is this one minus. Okay, so now we go down, so plus minus, so this is, there will be R2 multiplied with the I3, okay, equal to 0. Okay, so we will have 20. Okay, let us put this way. We will get to, okay, bring minus over here, so we got I1 is 2 ohm, so now 2I1 minus, well, I is 1x, so this is 1, so di1 divided by dt, okay, minus R3, sorry, R2 here, this should be R2, so R2 is 4 multiplied with I1 I3 equal to 20. This should be plus, okay, 20. Okay, so this is at loop 1, so at loop 2, okay, so this loop, so at loop 2 is same, so let us start, just now we start from B, okay, not B, at loop 2 from, at loop 1 from not, not B, okay, at loop 2 from not B, okay, sorry, from not B, so we will have what, this is not, so you can see loop 2, now current go again I3, so this will be plus, right, so we got R3 R2 I3 minus, this is plus, so now it's like this, go again I2, so it will be I3, so I2 I2 and then minus inductor here, okay, like this, minus L2 di2 divided by dt. Okay, we got 1 2 3, I think it should be okay now, equal to 0. Okay, so we got R2, okay, R2 is 4, so we got 4 ohm multiplied by I3 minus R3 is 8 ohm, so this is 8 multiplied with I2 and minus L2 is 2 di2 divided by dt equal to 0. Okay, so you can see now we have two equations. This is one equation, this is another equation. Okay, alright, let us copy this. So we have 2I1 plus di3 di3 sorry, di1. Okay, di1, di1, sorry, di1, not di2, di1 dt plus 4i3 equal to 20, and then we have another equation, 4i3. Okay, so we arrange this one, 8i2 minus 8i2 minus 2 di2 dt, and plus 4, okay, plus 4i3. Okay, 4i3 equal to 0. All right. Okay, so basically this is the equation. Okay, so basically this is the equation that we can get from here. So if we um, okay, so if we talk about the governing equation, so this is the governing equation. Okay, so we complete the governing equation. So this is the governing equation that we have. Okay, and then show that the circuit can model like this. This is the tough one, because from here I don't think we can get the second order of ODE. Okay? We can try, so that's why I said I'm going to ask my college in electrical engineering to help us how to solve this one, how to make it uh, until second ODE, because in second ODE, unless we have the capacitor, right? When we have a capacitor, for example, let's say we have a capacitor like this, okay, we just see, then we can have a chance to have the second ODE. But here we have only one, so we have only the first ODE. Okay, let's try it again. Let's continue. So we have this. So if we would like to omit I3, okay, if you would like to omit I3 also can, we multiply this one with minus, multiply with this one, okay, minus here. So we multiply with negative here with everyone. So we will get, this one will be 8 I2 minus 2 di2 divided by dt minus, should be plus, minus 4i3 equal to 0, right? So this one will be 20, we plus, so we have 2i1 I2 plus di1 dt, okay, dt, and this one will be 0, this one and this one, so it will be plus 2 di2 dt equal to 20 plus 0 will be 20, equal to 20. Okay, so that's the equation that we can get. Okay, so meaning we already have I1 and I2, I1 and I2. Okay, and don't forget we have I1 equal to I2 plus I3. Okay, so okay, so this part I think I will ask electrical college to help me to work it out. Okay, all right, so let us skip this part, I mean demonstration of the second ODE, and then let's go to the B. Okay, solve the resulting equation by solve guesswork. Okay, so we take this one. Okay, so this is B. So B is literally we have d square I2 divided by dt square plus 12 di2 dt plus 28 I2 equal to 40. Okay, okay, so we will get, let, okay, I equal to I2, so replace with I2 with I. It's easy for us to do this, so it will be, okay, I dash double dash plus 12 I dash plus 28 I equal to 40. Okay, so based on, okay, we work with the guess. Okay, so we work with by guesswork. So as you know, I is equal to, okay, IP plus I, particular non-homogeneous solution, and this one is a general solution of homogeneous ODE. Okay, so IP here. So we have, so let us find the solution of this. Okay, let us find the solution of I. So I, we got I dash plus 12 I dash plus 28i equal to 0. General solution of ODE, okay? So let I equal to E lambda x, okay? So we will get I dash equal to lambda E lambda x and I double dash equal to lambda square E lambda x. Okay, so if we replace this one inside, so we will get lambda square E lambda x plus 12 lambda E lambda x plus 28 E lambda x equal to 0. So we will get E lambda x lambda square, right, plus 12 lambda plus 28 equal to 0. So this one is different from 0. So we will get lambda square plus 12 lambda is equal to, plus 28 equal to 0. So this is a quadratic equation. Okay, so we got this. So actually I find lambda 1 and 2. Lambda 1 is equal to, please do it by yourself. I find it's 0.16 and lambda 2 is, I find it's equal to minus 12.16. Okay, 12.16. So I will get I is equal to A E lambda 1x plus B E lambda 2x. So I will get A E 0.16 x plus B E minus 12.16. Okay, and then how about IP? Okay, so this is IP. So we got IP dash plus 12 I dash P plus 28 equal to 40, right? So let's try. Okay, alpha, sorry, IP equal to alpha. Okay, so we will get IP dash is equal to 0, and IP the bus dash will be equal to 0. So we will have 0 plus 12 multiplied with 0 plus 28. Sorry, this is IP 28 alpha, okay, is equal to 40. So we will get alpha is equal to 40 divided by 28. So it will equal to 1.43. Okay, so IP equal to 1.43. So we get I is equal to 1.43 plus A E 0.16 x plus B E minus 12.16 16x, then is equal to, sorry, this is not x, okay, it should be t, sorry, this is t, should be t, should be t, should be t, because our variable is time, not x. We used to have x, so that's why it become x everywhere. It should be t, okay. Okay, so this is t, okay. Okay, so we will get A, we got, okay, we try to get, we got A, E 0.16 T plus B, E minus 12.16 T plus 1.43. So that's the I. Okay. Okay, so that's it for this. Then I hope please do it by yourself. Try it. I mean, practice it again. Okay. So we move to the next section, which is Laplace transformation.